So hello guys, today we'll be doing on this cloud computing and Azure. So before going to technical details of cloud computing and all, let me just share a small story with you. So when you turn on a light of your home, what do you think? What comes in your mind? Probably that the light would go on. But have you ever thought that there's someone producing electricity, or how the electricity is transmitted through this high voltage line to your home or to your town, or what happens in the substations? Probably not. Probably you haven't thought of these issues. And also, when you are buying a electric bulb, have you ever paid the electricity provider for this? I guess not, right? So what do you actually do? You pay for what you use. What is the amount of electricity you use for in your home is what you pay for, right? And secondly, in this example, if you just dig into, you don't actually worry about what's the technology that the power plant is using, or how the power is generated. Is it through coal, or is it through nuclear energy, or whatever it is, right? So this is not something what inspires you or what comes in your attention. Also, if you just think of another situation, like whenever say a new family or a new people comes to stay in your town, so do you ever thought like, would the power voltage decrease for you, or power voltage live like stay the same as it was? Probably all the answers to these questions are no, right? Have As a technology professional, if you just think of this situation while you are developing or deploying any applications, right? You simply love if these benefits are with you. That means you don't have to think of what's going on behind the thing. You're just concentrated on developing your part, right? So that would be a huge benefit for you. Say you are streaming videos, or you are storing data, or you are trying to host a website. So what you actually do when you are doing these things, you actually manage the hardware and the software. Talking as a technology professional. As a professional, you just need to manage the hardware and the software too, right? Only writing few lines of code won't do for you. You need to think, what's the CPU that would run my code? What's the RAM that would run my code, right? In this scenario, what would happen if you just go like get rid of all these obstacles? To get rid, we luckily has a solution for us ready, that is cloud computing with us. So that's how you can think cloud computing is. The next important thing you just need to head on is, what is cloud? Okay, that's a common question, right? Everyone now and then comes and says, what is cloud? What is cloud? Right, probably it's raining somewhere and you can think, oh, there's a cloud raining too. But I guess that's not what cloud and cloud computing actually mean, right? So I'd actually love if you just share some of your views, what you think of what is cloud, or what is cloud computing is, and share your thoughts. In that meantime, I'm just roaming out something like, say you need a storage space, or you need CPU cycles, or you need a RAM to run your system. So these are some of the resources you just need when you are trying to develop a solution or develop a product, right? So what would you actually do as a company, or not as a single individual? Think of a company, and what would a company do? Probably they would not go on buying all the resources. They may not have that budget to buy that huge amount of resources that's required to increase the CPU cycles, or the increase the storage space. For increasing storage space, you may need a huge data center for your company too, right? So I guess you guys have any idea of how Facebook data center, or how Google data center looks like. You have an idea of how huge the data center are. So what would you do as a company when there's a problem of you that you need CPU cycles, you need storage space, and you don't have budget? That's come cloud computing. And what is cloud computing? Cloud computing in layman's term is just renting of resources. What resources? You are just renting the resources like storage space, CPU cycles, RAM. Where? Where are you renting from? These are not on your computer, right? So you are renting those from any other company's computer. And how you pay for that? You just pay whatever you use for. Remember the electricity example. You just pay for how many units you actually use. You don't pay for the whole area or how the electricity is produced, or where it is stored, how they are transmitting. You don't pay for all that. You don't have any idea. You don't need to have a thought of all this while paying for the electricity, right? The similar goes here. You don't need to think how their CPU cycles are, what are the current updates in the CPUs or in the software systems that they are providing you, or what is the storage space you are using. You are just paying for what you are using, right? So here we have cloud computing that is just renting of that resource. And if I just give you some of the cloud providers, who are these cloud providers? Those companies giving you the cloud service. Obviously there's a cloud providers, and you can say that's basically there's Microsoft is there obviously with an Azure. You can say Amazon is there with AWS. Probably many of you have learned or heard of it. Also, there's Google's there. There's IBM is there, and there's many more companies who have their own cloud service available. So after that, we need cloud computing services. So what the service that this cloud providers actually provide you? Okay, so cloud computing services are the basic requirement you need. Okay, so if you just think a little deeper in this way, that what is the goal of this cloud computing? That's basically to make your business easier, to make your business more efficient, or like whether it is a small startup or a large enterprise, right? For every company, it's a try to lower your budget, like company budget. When you're starting a startup, you don't have huge money or budget with you for buying a huge resources. So the main goal is the main goal lies with the business easier, making the business easier. Now you need some services from the cloud providers. So this include the compute power. Okay, so you need what? A compute power. So compute power means you can say that the Linux servers or the web servers, yes, the web application, the Linux servers that they provide or that you install on your machine, on your local machine, is the compute power. Now cloud provides the same thing to you. And suppose as a customer, not as a developer, if you just look into this thing, as a customer, you can say, like when you send an email, or say you just trying to book an online reservation. Sorry, it's a lockdown and you can't book reservation now. But think of the situation when you are trying to book some reservation, or when you're trying to pay your online bill. Then what you actually do? Or suppose you were right now streaming YouTube, right? So streaming YouTube and all these tasks you were doing over the internet, what is this task actually? You're just interacting with the server. Remember, you are interacting with nothing but a cloud-based servers. Okay, so we all are dependent on this cloud services. Okay, as a developer point of view, this was as a consumer point of view. Now focus as a developer point of view. So when you build solution using cloud computing, you can choose how work can be done. Okay, based on uh, computing, or based on your resources, your needs. You can just choose how the work can be done. And if I just give an example here too, like if you want to have more control and responsibility over the maintenance, like on the softwares or the maintenance, so you can actually create a virtual machine, VM. So what this actually comes around? A VM can be something you can think as an emulation of your computer, or emulation of the computer or the laptop that you have, the desktop that you have in your home is just emulation of your computer, but on a virtual basis. Okay, so a VM, a virtual machine, is a emulation of the computer, and each virtual machine, as you can see in this diagram, has a virtual hardware for you, an operating system for you, and obviously some Windows, Linux are there, and you can run your app on that system. It's basically a replication or the emulation of what you get. So the difference is that you don't have to buy any of the hardware or install OS. You are not paying for buying huge hardware or the high graphics, high hardwares. Okay, so everything is there for you, and you don't need to think of installing OS. Okay, so call some technical buddy and install your OS. Okay, that's all you don't need to do. A virtual machine is ready to go in minutes, and obviously at a low cost than a physical computer. So that's why you will move, right? When you are saving money, that's the reason when you move to cloud, you just need to save money, right? And there are other options as well. As a cloud, when you're in like hosting something or using cloud, you can have other options. You always don't need to pay for virtual machines. Maybe you don't need a whole virtual machine to work on. You have some machines in your workspace or in your company, and you just want some other kind of functions or other kind of tasks to be done in the cloud. So other thing you can say a container. So containers are basically you can maybe George Pool containers, PUBG. So you can say that there are some containers where you can store something. That's a container, and how what it does for you, it is an isolated execution environment. Okay, so it provides the environment where you can just put your app and put all the dependencies into a package and put all of them into this container and run it. That's what you need. And similar to the virtual machine, except they don't require an operating system. So you can understand that in this you are just putting in this app. There's a you can see in this diagram that only the app is there and not the virtual operating system is there, right? And the benefit of using a container is that obviously it comes at lower cost than virtual machine, and you can say you don't need any ways to boot and initialize, and hence you can launch it in minutes or seconds. For virtual machines to launch it, it may take a minutes, but you can launch a container in seconds. So you're just done with the app and the dependencies using it. The next thing you can do in a server is a serverless computing. Sorry, in a cloud computing, you can do is a serverless computing. So what it does, serverless computing actually lets you run application code without configuring or maintaining a server. Okay, so you are not setting up any server or any hardware or any virtual hardware that those you are doing in the virtual machines or the containers, but you are particularly running a particular function or a small piece of code that you actually need to run when you get any trigger. Okay, I'm going technical. So let's take an example and see what the serverless computing does for you. Suppose you want to build a serverless process that is the automatically send an email after the customer makes any online purchase. So consider a situation like you're developing a system for the e-commerce website, and somehow you need to send a confirmation email. So what you will do, you just create a function, right? You just need to create a whole application for sending a confirmation email, and you don't need a whole application too. You can set up a trigger that whenever an online purchase is done, send a receipt or send the confirmation email, right? And you can hope you can understand what these functions or does when a triggered is executed or when they're called. So again, you only pay for the processing time used by each of the function and as it executes. So you are in this case you are not paying for the space or the whole thing, but in the serverless runtime you are just paying for what the that the processing time the function needs to run. Okay, for that time you are paying. Obviously, you can think of the electricity example again. You are paying for what? You are paying for that how many hours you are using the electricity, right? You are measure electricity in watt hour, and in the similar case, you just pay for those functions for how many for what the time the processing time it needs. For containers, you pay for how long or how what are the applications you are taking in the containers. And for virtual machine, you are just paying for the virtual machine of how much space you are using it in that terms. So that's the storage. Sorry, that's the computing power of an cloud system, right? For a cloud system, you can consider this kind of computing power. But yes, there are other services too that a cloud system provides, and that's includes one of the most important service is that storage. Okay, so storage, you can say as an example written here, you can see you need to upload files or you need to upload databases. Obviously, might be some of you have experience with writing a web application or say writing a HTML code. And I know some of you have experience with writing HTML code and hacking NASA with it. But yes, that's a part. But yeah, you need a storage space to host it, to host your application, right? To actually just host the whole thing. So for storage space, you can say what you do for storage space. You can, if I give you some example, like you may use the most buying a movie ticket. So on buying a movie ticket, you just need to store the data when it's bought, or you just need to keep a record, right? For that, it is a database. And when you're taking a picture, say you are uploading a picture to Google Photos. So what happens? They're storing it somewhere, right, for you. That's what. Or you're sending an email, right? say you just sent an email from your server and it just sent, and where the records are kept. If the records are somewhere kept, and that you can say as an storage space, right? There are other two services that cloud computing provides you. Are you can say the networking, the such as a secure connection they give between your cloud provider and your company. You don't need to think of the security part, right? You know your data is secure. Whenever you host your personal website somewhere, so you are getting sure that someone will not use your data, like the data you provided on your personal website. Someone will not use it. Like someone will not extract it from the backend and sell it to someone else. Obviously, so whatever you want, you get the security too. The next thing is the analytics. Yes, analytics is an important thing that cloud service provided. Many of you have an example working with Google Analytics, right? Google Analytics provides a huge telemetry of what your particular website or how your particular website is performing. A similar way, every cloud service provides an analytics. Whenever you are hosting or taking a virtual machine, or say you are taking container or whatever serverless computing, also you can get analytics of how much is the telemetry or what's the performance data, what is happening inside it. So that's how the cloud computing service. These are the most important cloud computing services. These are not limited to here. You can use AIML on your cloud computers too. These are also supported, and there are a lot more cloud computing services that include. But these are the four important cloud computing services. The next thing that we will look into is the benefits of cloud computing. Okay, so for the benefits of cloud computing, you should understand that cloud computing isn't an all or nothing service approach. So what I mean to say is either you need to buy all or you have nothing service approach. This isn't cloud computing. So companies can choose to use cloud to store their data and execute logic as much or as little as necessary to fulfill their business requirements, right? And that's the point. You say that you pay as you go. And then, like that, existing businesses might choose a gradual movement to save more money, right? Or they need an infrastructure or an administration cost. Like they can save money from that infrastructure by moving to cloud. And obviously, there's new companies that might start in the cloud as well. So for any company to start in cloud or for an existing company to move to cloud, there must be some benefits. Like every company is money oriented. No company wants like their company goes in loss. No one wants this kind of thing. So every company is money oriented. So you need some benefits to move into cloud, right? And the first benefit is cost effective. Yes, it's cost effective. How? Like you pay as you go. What does it mean? The consumption based pricing model is there. Whatever you consume is the price that you pay for. Similarly, take that example I gave in the beginning, a story of the electricity board. You will just pay for what you are using, how many watts of electricity that you're using, right? Similarly, you pay here as you go. As much as service or as much as data or CPU cycles you're using here, you are just paying for that. The next thing comes up is the scalable. So any increase or decrease in the resources and services based on demand or workload at any given time is scalable. Like what does I mean with that? Say you just need you're owning a say e-commerce website and you put up a sale over there. So what would happen? Suddenly, for the sale, a huge crowd would come to your site, right? And for that huge crowd, you need a high-end infrastructure to handle that cloud, or else what would happen? Your e-commerce website would crash. Like this is the layman's term, we say that the website crashed, right? And this can actually happen. But in cloud, this is scaled. How? Whenever you need say extra CPU or extra memory, this gets added up automatically. If you want this to be added up automatically, it will be there automatically. Or if you want something like if you want more servers for your system, you can also do that. So that's how you scale it. So there are basically two types of scaling, and we call it as vertical scaling or horizontal scaling. Okay, so vertical scaling is basically scaling up. How you just when you need an extra when you just need to increase the power of your existing services, so what do? You just add the CPU, you just add more memory space to it, and that's how you just scale up your device, like your service that's going on. You just scale up. And also we have that horizontal scaling. How what it do we do in it? We do like when we need any more servers that work that we need. Like suppose we are trying to separate all the incoming requests to to your website to one server and all the outgoing requests of your website to another server. So you need two servers working at one unit. So you need to scale up your device or scale out your device, and that can be done in cloud either manually or automatically. So for automatically, you need to set up a trigger also. The next thing that comes as a benefit of cloud computing is it's elastic. So what happens? With a change in workload due to spikes or drop in demand, cloud can automatically compensate adding or removing resources. It's a work of a cloud. If you want the cloud to do it, so cloud will automatically add resources to your service or decrease resources to your service or remove the resources, existing resources to your service, and thus ultimately cloud is saving. Cloud providers are saving a cost. You are not paying for huge cost, right? That's how they just whenever you have a spike or you know that somehow a huge amount of customers are going to come in your website, so you just ask this like the cloud will automatically elastically like add resources to your service. And the next thing is the most important one that makes people move to cloud is its current. So what does it mean with its current? So you can say like while you use cloud, you are able to focus on what matters the most. As a developer, what matters the most is building and deploying application. Obviously, when if you are developing a Python application, you are least interested when a Python update is there. Or sorry, you are least interested when a pip install update is there, right? And you're like you don't know that you don't want to install, like update pip, right? Pip to pip 3 or the latest update. So obviously you just feel bored when the command prompt asks you to update pip. Hey, your pip is out of date and update it to the latest version, right? For cloud, it's something different. The software patch maintenance, hardware setup, upgrades, like the hardware maintenance, and every task of an IT management, like a IT manager or a IT management task that needs, every task is maintained by cloud itself. So it automatically updates PEEP for you. You don't know if the compiler won't ask you, hey, PEEP is out of date. So that's how the cloud computing is automatically current for you. You are always using the latest hardwares, latest softwares for them, from them. That's how it maintains its latest current environment. The next thing that comes is it's reliable. How do you rely on this system? Right? You are storing your valuable data. You are storing your data of your e-commerce site. You are storing everything of your business on a cloud. So you must rely, you must trust that service, right? So how do you trust? Like somehow, if your data is lost, you may have a question. Hey, I am putting out my data over the cloud, and somehow someone takes it, and I am lost. I have no data with me currently to run a business. So that's cannot you cannot prefer or you cannot allow that, right? So for that purpose, you need to have a trust over the cloud. So how does cloud ensure that you have a trust over it? Right? So for that, cloud computing offers you something like it gives you the data backup, and obviously disaster recovery system, and what a data replication service to make sure your data is always safe. In case if the components in the cloud or if the particular data center of your cloud provider fails, always there's a backup component ready with them that takes the place. So what happens whenever you are putting up something over the cloud, always remember a backup is ready for you, a disaster security recovery is ready for you, and the data replication is ready for you. So what does data replication mean? Suppose your data is hosted on the data center of that cloud provider in India, okay, and by any natural disaster, suppose that data center gets damaged, okay, now what will happen? You will say that, hey, my data is lost. No, this will not happen in this case. So what will happen? Always there's a data replication of your data in some other cloud that the cloud provider managed for you, and whenever the particular data center damaged or gets some damage, automatically that replication data would take your place, and your service, that your website or your application would go seamlessly. You would not face any trouble for that particular damage to the data center, right? That's the task of your cloud computer or the cloud service provider. That's how you rely on the cloud computing. And the next thing, yes, obviously it's global. I gave an example to you that if your service in if your system is hosted in Indian server and somehow it gets damaged, yes, it's a global, so it's access all over the world, and you said various data centers so that you don't face any problem. Also, suppose you are a big business, you have a huge company and your company needs local, like whenever you have a huge company, if you're jumping on various servers to reach your customers, say your company has a customer from German, and that's how it will be a great, it will take a great loading time for that person if he's using a different server, right? But whenever you are hosting it in the cloud computing, always remember it will be the your data will come to that user from the nearest server. So how it's happening? In that case, they keep the replication I told you, and hence you can actually maintain the customer and give the best response time for your service. The another important thing, and that's the most important, I guess, is this: it's secure. How secure it is? Think of how your data centers are secure. Like you can think, hey, I have uploaded it to a server, and server is somewhere. Like it's not on the actual floating in air, right? It's not there. So it's located at some place. So what would happen if someone breaks into it? Okay, there's maybe a robbery or whatever it can happen in the physical robbery can happen. Say hackers can peep into it, right? So you might have this kind of questions, but remember, it's secure. How secure it is? You have both that physical security and digital security. The digital security is maintained by the cloud computer, like the cloud service providers itself. Also, that physical security, for the physical security, they give you a policy that who can access the data center, what the data center is, like how a data center maintained. There, so you can read all that. What are the security measures they're taking to keep your data safe, right? Next, we'll move to some of the business aspect to it. First, the business aspect. So you have heard about capital expenditure and operational expenditure. These are some of the economics terms I'm putting in. And say capital expenditure. What is that? Most engineering students might not have any idea about how that economics terms is. Yes, there are economics papers for you to learn, but I know most of you will ignore it somehow. No problem. So whenever it comes to cloud, there's capital expenditure. So what's capital expenditure? Or capex, we call it in short, is basically the major purchases that a company makes that are designed to be used over a long time, right? The company may buy like it needs infrastructure, say it buys a land for that. This is the capital expenditure. They're investing for a long term, right? These are the capex. And what is the opex? So OPEX are basically the operational expenditure that I'm saying. But what is that? It's the day-to-day expenses a company incur to keep their business operational, right? For keeping a business operational, you need to make many expenses on a day-to-day basis. Those who have experience on business, they can say it more clearly. But sorry, I don't have. I have never owned any business on a day-to-day basis or made any expense for that purpose. Okay, so if you just look into what the capex has in terms of your tax benefits, right? You just somehow you need to send your tax, right? Everyone thinks in that way. So if you say the capex for capex is that the tax is deducted over time, and the as the asset cost is as the asset cost is depreciated or amortized. But in case of OPEX, you can say that the fully tax deductible in the year they are made. For the OPEX, you just get a tax benefit for the particular year, right? And there's few things that capex falls under, like on-premises data centers have capex, and for that you have uh, server cost, and you have storage cost, then you have a network cost. You just need a hardware, you just need LAN switches, access points, routers. Okay, this kind of thing you have as a capex cost. And okay, am I audible? Yeah. Network cost, and then it comes about the backup or the archive cost. So there are many capex costs, the data center and infrastructure costs, or technical personnel you are hiring to for your task. Those personnel, like your employees, these are all capex, falls under capex. But for OPEX, the thing is not the same. So just if you just look into the benefits of CAPEX, you can say that with capital expenditure, you can actually plan your expenses at the start of a project, or you can actually get your budget done, right? You can get your fixed budget for the purpose, but that is your cost are fixed. You don't have anything like any sudden cost that come in. And this may be appealing that you can get you can start with limited budget, right? You can get an exact idea with how much the cost would be. That's how the capex may be beneficial. But for opex, just think of the situation when the demand uh, grows, say, unpredictably. And again, I will take the example of the um, say your e-commerce website. So suddenly, and you put up a sale for some product, and the demand increases, right? And the demand can be many folds higher than your expectations. And so in this case, the capex model has a challenge, right? Just look at this figure I put up here. If you just look at this figure, you can see that the green line that you can see is that actual demand prediction that your CA or anyone someone did it for you, that the demand it would stay somewhere here. So as the demand increases, the red line is the capex expenditure. So the capex expenditure, you just go on increasing your capital investment expenditure. So the red line goes up as the demand goes up, the demand expectation goes up. But somehow, look at this third area, your demand expectation exceeded the infrastructure. So capex, the red line, that is, you have that limited infrastructure ready, and your demand exceeded your expected value. So what would happen in this case? Again, a crash. Like use in layman's term, we say that is the website crashed, and that's how you'll see the website is not really responding or it crashed somehow, right? And look here, if you just look into it more details, then you can see that after the like the graph, you can see the actual autos like the actual demand falls from the demand prediction much like with the higher scale, right? The similar way it went up, it can fall to a much lower end. So what we can do here, we can actually go with an auto scale. That is the blue line you can see. That's how auto scaling helps you, that it automatically scales, that whenever your demand is increasing, the auto scaling helps to add more resources to your particular server or particular service. So whenever the auto scaled you are using auto scale service over a cloud server, you can see that your website actually never crashes. Why? It automatically controls it. It automatically adds resources to your service. It automatically takes care of the expected investment or the expected um, cloud, or say expected how many people will around come here, right? The next thing, we'll just look into the cloud computing, is a cloud deployment models. So this is something most important. What is that? Once you decide that you want to shift to some, you want to shift some of your applications into cloud, and the next decision you have to take is how to deploy, right? That's a tough question, how to deploy. So there are basically three ways you can deploy or integrate your cloud services into your application architecture or an infrastructure. So the first and the most, this is the most common and the approach is that the public cloud. So before I go in details, let me just tell you that there are basically three kinds of models for cloud deployment, and that's public, private, and the hybrid cloud. So in public cloud, all the cloud resources such as your servers and disks, all are owned and managed by the cloud provider itself. Okay, so the cloud providers in this case, say Azure, and access and deliver over the internet. They take your, you keep all your resources there, and they just provide to the end user customer directly over the internet, right? And there is a physical hardware, and that is shared with your other organization. Remember, that's the important thing you need to know about public cloud. You know you have rented a space from the cloud service provider, but remember, in a particular CPU disk or say a GPU disk, there's a lot of space. Like in a hard drive, there's a lot of space. And your say the hard drive is a 1 terabyte that is kept in the cloud, right? That is kept in the cloud data center, but you are just renting 1 GB for your particular system. So what the company or cloud provider will do, they will not keep it idle for you, that somehow someday you will just need an extra resource and they will increase that resource on that day. No, they will never do that. So what will do that, you always know that your data is shared with uh, not shared physically, but we've kept with other organizations data too. Okay, this is what private cloud, public cloud is. So you are just using 1 GB of the say 1 terabyte data hard disk that the cloud service have, and the rest of the data is taken by some other companies. Okay, so that's how public cloud works, and your data is secure. Don't worry, your data is not stolen by other companies, but is secure and isolated. But the cloud provider decides where to store it and where your logic runs. Okay, they just keep control of the place they want to store it, but and also where they want your program to run. just not on a string, it needs to run too, it needs CPU cycles too. So they just decide all that. The primary approach to this is cost. You just pay for what you use, right? This is the primary thing, and you scale on demand based on your needs, and there is no need to purchase or maintain expensive hardwares, right? Obviously there's no need for that. Then if you just okay, wait, yeah. Next thing is that the private cloud. This is the second most commonly used approach in the is the private cloud. And what's that? This is where computing resources are used exclusively by one business or organization. You are just getting some space for your particular organization, and you just know where you are storing it. It can be a physical. It can be physically local. It can be physically located on your premises or managed by cloud providers, right? You just need to support this. But as a cloud service provider, you can use this, like Azure supports this too. You can get a private cloud on Azure too through Azure Stack. There's something called Azure Stack, and you can get your private cloud on that, but it's a bit costly too. But why will you use the private cloud? Remember, there can be some policy agreements with say some government agencies, or they need to store some data, so they probably don't won't share their cloud with some other companies, right? They don't want any of the government data to be get leaked anyhow, right? Yes, there's no chance of leaking in the public cloud, but yeah, there's policy agreements, and that's why you need a private cloud. Yes, there's you can think of another example. Say you are taking some financial institutions as an example. If I give you, like if you are the head of the SBI, State Bank of India, and somehow you need to store your data, your customer data, right? So obviously you won't get a public cloud. You anyhow you just want this data to be more secure, right? For that you just go for that private cloud thing, and this is basically the getting a more like you just shape your requirements and you get your cloud. And the third important thing is the hybrid cloud. Probably not that much used on, but yeah, most companies are trying to implement a hybrid cloud as well. So what this means, it means that some of your applications and data are sorry okay this means that some of your data and applications are running on your private infrastructure, and some are running over the public cloud on Azure. So you are using a public cloud and your private infrastructure too. That we call as hybrid cloud. So how do you actually use it? There's a way you can think of using it, is that you can actually say there's a huge workload that suddenly came on your infrastructure. Okay, this is a example. You can say old companies, huge big companies that are already in the market, not the startups. Okay, so they have infrastructure already present in the market, and somehow a huge workload came in. So what would they do? They would just trigger up some spaces, or use take some spaces from the Azure, and at that point, like, you just burst up workloads to leverage Azure, to leverage Azure. And for this purpose, you just use the hybrid cloud. You use your own infrastructure and use your Azure cloud as well. At the same time, whenever your demand goes down, you just push down your work from Azure back to your internal resources. So that's how you just maintain your server response and everything, and you are using your own infrastructure, and at the same time your like you are using the extra resources from the public cloud. That's how you use the hybrid resources. Yes, there are other uses of hybrid resources as well. You can use it in different ways too. So no matter what your organization needs are, you can be confident that between public, private, and the hybrid cloud, there's a cloud deployment option that you need, that's right for you. Okay, so you can just find out your right choice for what you actually need in this case. And the next thing, this is what cloud services are. So types of the cloud services. So for the cloud services, there's basically, you can say, the three different types of cloud services are present in market. So you can say one is the infrastructure as a service, and if you just look into it, we call it IaaS, infrastructure as a service. So infrastructure as a service is the most flexible category of cloud services, remember. So what it does, or what it aims, it actually aims to give you a most control over the hardware that runs your application. Like, you have the maximum control of your hardware. Okay, remember, this is it is a shared responsibility. So in this infrastructure as a service, cloud service, and this type of service, you actually share the responsibility with the cloud providers as well. So what's happening? The cloud infrastructure is functioning correctly. Whether this is functioning correctly or not is basically taken care by the cloud providers. Whatever the cloud infrastructure, that is the only the CPUs, the RAMs, or the storage space, or the whatever the infrastructure you're using, whether it is working correctly or not, is the responsibility of the cloud service providers. Okay, but whether your service is configured correctly or not, you just configured your system with them, sorry, your software, your application with the cloud or not, that's the responsibility of you. Whether the application is up to date or not, your data is up to date or not, is the responsibility of you. Whether you like whether you're available to the customers or not, whether customers can see your page or not, is the responsibility of the cloud customer, like the you who are developing it in the cloud. Okay, so this can be used in, say, migrating workloads. Say the same thing I called in the hybrid cloud also, that whenever you're migrating workloads and you just need something like small steps in that, so you can use that. Next thing is whenever you're testing and whenever testing and deployment, or the deploying it into the service, you can say you can use infrastructure as a service. Also, whenever you just need storage, you just need backup, or you just need a small recovery facility, you can use infrastructure as a service. So cloud is not, the cloud service providers in this case is not responsible for whatever you were just putting up or whatever you were doing, whether the service is working or not. They are not responsible. They are only responsible for whether the particular hardware or the particular operating systems there you have rented for them, whether they are like those things are working or not. So that's what infrastructure as a service binds to the cloud service providers. The next thing that comes is platform as a service. Okay, the name says it gives you a platform. Okay, so platform as a service, you can say the mostly used one. Why? So it gives you a platform for, say, a complete development and deployment environment, or a platform for you that you can use for building, testing, or deploying your application, like your software applications into it, right? So you can use the platform as a service as a complete platform for all your tasks that you do on your local machine. Okay, so just like you can create an application without managing like the underlying infrastructure. So whatever the operating system or whatever the system updates are there or not, so you are not managing all this, right? This is, in this case, is managed by the cloud providers. So this is what you will use in normal terms, right? You will not use infrastructure as a service in normal terms, or you will not use those like, no, I mean, you will not use the infrastructure as a service in the everyday life. You just, whenever you are as a student or starting with cloud computing, you just move into this platform as a service. And as an example, if I give you as a platform as a service, you can say the database that you are using from Azure, or the Azure SQL database, is basically a platform as a service. Okay, the next thing that comes is software as a service. If you have attended yesterday's session by Pratik, then you remember that he mentioned that Power BI is software as a service. So you are getting a whole software as a service. So you are responsible for what? You are responsible for only hostel, like using the software. As an end user, you are responsible for using the software. So in this case, software as a service, you are paying for what? You pay here as a subscription fee. Okay, but for other two, infrastructure as a service or platform as a service, you pay as you go. Like whatever service you are using, you pay for that. But for software as a service, here you need to pay as a subscription fee, say a monthly subscription fee or a subscription fee. As an example, I already told that software as a service can be a Power BI. Yes, Power BI is an example, a good example, obviously, for maintaining that. And another example of software as a service, you can say, Office 365, that is the Word, Excel, whatever you there, you can use in on cloud too, right? Office 365 is there, and that's the software as a service. And if I give an example of this infrastructure as a service, you can get an examples like you are using something like virtual machines. When you're tackling a virtual machine, you are taking infrastructure as a service. So for the virtual machine, the cloud providers are responsible for the whole system you're using when it needs update or whatever it is, but they are only responsible for the basic infrastructure you're taking, right? So as an ownership point of view, if I just differentiate between infrastructure platform and software as a service, then you can say that as a user ownership, the user is responsible for purchase, installation, configuration, operating systems, and then applications and everything in infrastructure as a service, but in platform as a service, the user is responsible for the development of their own application. Okay, so you can say the containers or the serverless computing. The examples I gave in the beginning can be a part of the platform as a service workflow. Like, and when you're using the server as a when you're using the software as a service, then you can say that the users just use the application software. Okay, they are not responsible for maintenance, management of their software, how the software works. The users are not responsible for that. So that's how the software as a service works. Then there are a few management responsibilities. You can see here, like if you're creating your own cloud, then it's on-premises cloud. Say you're creating your own cloud data center for that. You are trying to create a duplicate of Azure, the whole Azure that provides you, trying to provide it. Then you are creating something called on-premises infrastructure. So it's a huge costing. So leave that apart. So as a service, you can see there's three: soft infrastructure, platform, and software. Here you can see the exact difference. For infrastructure as a service, the difference lies here that they are providing the networking, storage, servers, and virtualization in infrastructure. But in platform, they're adding something more. They're giving the OS also. They're giving the middleware. They're giving the runtime. These are all covered up in platform. But in software, they're giving only the service to you. Okay, the exact software service. You are using Power BI to develop your apps with no code or less code approach, right? You saw it yesterday, and you are using the Office 365, and that's how it runs in that manner, right? And the next thing that comes is this Microsoft Azure. So what it does for you, okay, Microsoft Azure is, or like Azure, or you can say Microsoft Azure is basically a service of Microsoft and cloud service of Microsoft, right? Or the cloud computing platform for you. So what it does, it provides a huge number of services, like more than 100 services that enables you to do everything from running your existing application on virtual machine to exploring new software paradigms such as you can say intelligent bots or mixed reality. Yes, you will see how to deploy a bot in the next hub, and that's how you can use it for you can use Azure for the purpose, right? And you can use it for networking. You can use it for say identity, authenticate your users. So how your users coming to you, you can use Azure for that purpose. And obviously AI and ML are something that became common for all cloud providers, right? And you can use Azure for that purpose. And finally, guys, thank you. And that ends to my session. And I'd love to have some questions if you have any. Please ask if you have any, or else we'll move on.
Please subscribe to this channel and like this video. Don't forget to press the bell icon so that you get notified whenever a new video gets uploaded.